All right, here is a video from the homework 2.2.1. It's problems 2-65, 2-66, and 2-67 here. So 3 problems from that homework. Starting with this one, examining the shape toolkit, something that we used earlier in chapter 2. That's something that you could go back in chapter 2 and find one of those older lessons and find that shape toolkit. Naming all of the shapes in the shape toolkit that share both of these following qualities. They need to have one line of symmetry, and that needs to have fewer than 4 sides, and so we're kind of strictly restricted to triangles here. There's 2 answers here. I'm going to try to draw them out the best that I can. One would be, and this is kind of an example that we would have seen on the test, something that looks like this, where we have this side equal to this side, and that would be our isosceles triangle. So our regular isosceles triangle that has this one line of symmetry that cuts it down the middle. That's the only one that it has. And then it has fewer than 4 sides, so it meets that criteria. And then we have one more, and it's very similar. Let's see if I can draw this one out. It would be something like this, where these sides are equal. And so I'll make the tick mark saying those are equal there. And then these ones here are equal. Okay, and that would be a right angle right there. And same kind of thing, because it has 2 equal sides and it's 3-sided. That's an isosceles triangle again. However, it is different in the way that that is isosceles right triangle. Okay, and then those would be the 2 that we had seen in that toolkit from earlier in chapter 2. And we would have, and I should put my line of symmetry in here to prove it, but line of symmetry would go somewhere right there. So that's question 2-65, 2 answers, isosceles triangle and isosceles right. Here we are examining the diagram, so 266. We are examining the diagram at the right, this diagram here. Then you're going to use the information provided in the diagram to find the measures of angles A, B, C, and D. For each angle, name the relationship from your angle relation toolkit and help justify your conclusion. For example, did you use vertical angles? If not, what type of angle did you use? So I'm going to focus right here first in, well, the 148, the C, and the D, because honestly, we're going to have to attack this in 2 different parts, because we have parallel lines cut by a transversal, so we have to focus in this kind of transversal area. And then we have parallel lines cut by a different transversal, and so we're going to have to focus on these separately. And so I can't just say, you know, because of this line here and this line here are not parallel, things don't work as nicely for us. So we got to focus on the parallel lines and one transversal at a time. Now, focusing here first on part C, or our angle for C, okay? What I notice here is that the C and the 148, that's creating a straight line there. So that's a supplementary relationship, meaning that I can find C by doing C plus 148. That needs to equal 180, because that's a straight line there. Subtracting over the 148 so that I get it onto the other side and I ultimately get C by itself, that leaves me with an angle of 32 degrees. So C equals 32 degrees, and the relationship is supplementary. And I'm just going to stop at sup because my handwriting is terrible on my computer screen. So there's C. We can find D. D is an example of a transversal cutting parallel lines. We have an angle on one side inside the parallel lines, and we have one on one side. We have one on the other side, so they're opposite. They're interior inside the parallel lines. That's what we call alternate interior angles, and we should know that alternate interior angles are congruent. So D is 32 if C is, and that is that alternate interior relationship. So that's good. Handle those 2. Now the next one, we have B and A. What I notice here is that 62, we could use a vertical angle relationship to say that this is also 62, right here, where the black dot is. So that's 62, that's 62. Now 62 and B, those are same side interior angles. So same side interior angles add up to 180. They're also supplementary. And so 62 plus the B value needs to equal 180. We can highlight these, those are answers. 62 plus the B value equals 180. I got to subtract 62 onto both sides, so I get B by itself. And B, what did we get here? It looks like it's going to be 118 for the B value there. Again, because that is a same side interior relationship. That's why I knew that was supplementary and I could add them together and set them equal to 180. Lastly, A is a vertical angle to B, so vertical angles are congruent. So if B is 118, A is also 118, and that is vertical angles. And there we have all of our answers to that one. One final problem here for 2-67. We have measure of angle D is 48. The measure of angle F is 117. What is the measure of angle E? This is a triangle sum theorem. And so we have 48 in the top corner, 117, and we're missing E. So what we can do, we know that all the angles of a triangle need to add up to 180. So 48 plus 117 plus my missing angle, measure of angle E, is going to have to equal 180. All right, well, we can add these two together on the left side. 48 can combine with 117, and I believe that to be 165, if I'm not mistaken, plus the measure of angle E is equal to 180. Can subtract 165 on both sides, and then we can be left with the measure of angle E equaling 15 degrees. And that is my first one, just using the triangle sum theorem. Part B is an algebra question, a little bit tougher here, and a more fun one in my opinion. We're ultimately going to look for the measure of angle D, but we have to solve it for x. And so what we again are going to have to do is this piece plus this piece plus this piece set equal to 180. So that's 4x plus 2. We'll change colors to know I'm on a different part. I got 4x. Oh, we didn't change colors here. 1 second. Let's erase that. 4x plus 2, that angle, plus my other angle, which is 7x minus 8, plus my third angle, which is 4x plus 6, equals 180. Now I gotta solve this thing for x. I am going to combine all of my like terms. So everything that has an x is going to get combined. 4x plus 7x, that's 11x. 11x plus another 4x, that's 15x. Okay, let's combine our non-like terms. So that's 2, that's negative 8, and that's a positive 6. Well, 2 plus a negative 8, 2 plus a negative 8, that's negative 6. Negative 6 plus a positive 6, that's 0. So that's nothing. And so that's just going to go away. And then we got equals to 180. All right, now we got to do 180 divided by 15 to figure out what x equals. Let's see if we can do this in our head. So we have 15 times 4 would give us 60. 60 times 3 gives us 180, so we can do 4 times 3, which should give us 12. Let's check that on a calculator. Does that calculate out correctly? So 180 divided by 15, that is 12. Nice, my math works. So x equals 12, but that's not the answer, because what we need to do is find angle D. So we need to plug that 12 into the angle D equation, which is 4x plus 2. So I got to plug it into the 4x plus 2, so that's 4. Plugging this in for x is 12, and then it is a plus 2. 4 times 12, that is 48. 48 plus 2 gives me 50, and that is my measure of angle D. Last one, if, and this is a quick one, nice, if the measure of angle D is the same as the measure of angle F is the same as the measure of angle E, what kind of triangle is that? Well, only one triangle has all equal angles, and that is an equilateral. So the last one is equilateral triangle. Okay. That's it for this video. If you have any more questions, always feel free to reach out and ask.